As you have probably noticed, up to this point in the module, everything we've dealt with only really looks at individual propositions by themselves. So, for example, we've figured out how you would take an individual proposition given in ordinary language and then convert it into symbolic form or notation. We've seen how you would determine the total truth value of a complex proposition when you already know the truth value of each and every simple proposition in that statement. And we've also been able to construct truth tables for individual propositions. At this point, what we need to do is look at how we use truth tables to determine the validity of any particular argument. And of course, that's our goal in all of this, right? We're studying logic precisely because we want to know how to tell if an argument is valid or invalid. And so we're finally getting to the point where we can put this together into a system that actually serves the purpose of argumentation or logic. Now, the first step in this then is to go back and remind ourselves what we mean by validity and to look at a couple concepts that are very important in this idea. Now, truth tables provide us with a rather standardized way of testing arguments for validity in propositional logic. Now, these can be insanely cumbersome and rather tedious to work through, but if they're used correctly, they are technically infallible. And in using a truth table to determine validity in an argument, what we are going to do is exploit the fact that a valid argument can never have all of its premises be true while drawing a false conclusion. If you think way back to the beginning of this course in Module 1, one of the things that I harped on over and over again was the simple fact that this basic formula necessarily implies that an argument must be invalid. If you have a deductive argument where all of your premises are true, but you have a false conclusion, then necessarily this must be an invalid argument. And if you think back to this basic formula, one that we looked at quite a bit in Module 1, the end game of a deductive argument is to produce what is called a sound argument. And a sound argument is an argument that is both valid and that has all of the premises as true. Now, if you recall, meeting those two criteria, that is, when an argument is valid with true premises, this will always produce a true conclusion. So sound arguments must have true conclusions. And if you remember, we can simply use this basic formula and the fact that sound arguments must necessarily produce true conclusions to prove the claim that any deductive argument where all the premises are true and the conclusion is false must be invalid. And the first step in our reasoning here then is to recognize that if we know that there is a false conclusion, then it must be unsound. And of course, if it's an unsound argument, that means it cannot be both valid and have true premises. Because if it were valid and had true premises, then it would necessarily be sound, and I would get a true conclusion. So if I have a false conclusion, it can't be sound, and that means either one of these two things must be a problem. It's either not valid, or it does not have true premises, or maybe both. But of course, in the formula we're talking about, where a deductive argument has all of its premises as true and nonetheless gets a false conclusion, the problem can't be on the premises side of this equation. And since one or both of these two parts, either validity or true premises, must be the problem, and since it's not the fact that we don't have true premises, this implies necessarily that it can't be a valid argument. So once again, it's a very important concept, and it is this basic little formula that is going to define everything that we do with truth tables in terms of deciding validity in an argument. Just keep in mind that the basic proposition is this: any deductive argument that has true premises and a false conclusion must be invalid. Any other possible arrangement doesn't give us any information of use. If everything in the argument is true, it might be valid, it might be invalid. If everything in the argument is false, it might be valid, it might be invalid, and so on. The only time we know something with certainty about the validity of an argument is when our premises are all true, but I draw a false conclusion. And if I ever find myself in a situation where an argument is even capable of doing this, then it is necessarily an invalid argument. So let's see how we use truth tables to determine the validity of any propositional argument. And so we can start here with step one. Step one says we need to symbolically reconstruct the argument, identifying our premises and the conclusion, and then state them in symbolic form. The next step is as follows. We want to lay out a truth table, placing the argument in a straight line with the premises in order, premise 1, premise 2, premise 3, and so on, and placing a single slash between each and every premise, and then finally a double slash between the last premise and the conclusion that's drawn. And I'll show you what this looks like in a minute. Step 3 then says to construct a truth table for each piece of the argument. So if I have, let's say, 2 premises and a conclusion, I want to construct a truth table for each and every premise as well as for the conclusion. And then step 4 is finally this. We want to look for any line in which all of the premises in the argument are shown to be true, but the conclusion is false. And if we can find a line anywhere in the truth table where this happens, where such a line exists, then the argument is shown to be invalid. But if we cannot find any line where all the premises are true, but the conclusion is false, this is concrete and necessary proof that it's a valid argument. Now at this point, all that's left for us to do is walk through a bunch of examples to see precisely how this is supposed to work in a step-by-step fashion. So let's start with the first example here. Let's imagine we have an argument that symbolically stated comes out to look like this. Premise 1 says, if P is true, then Q is true. Premise 2 says P is true, and then our conclusion finally says Q is true. Now, whatever P and Q stands for at this point is not really relevant. This is the argument with both premises and the conclusion stated formally. So the very first step is to simply lay out a truth table, and that means simply lines as you see them here, perpendicular to one another, and then take each and every simple term in the argument, in this case there are only 2, P and Q, and set them on the left-hand side of your truth table. And now we can determine the total truth value of these 2 terms in the argument as a whole. And remember, if I only have 2 terms, this means I need exactly 4 lines in the argument as a whole, and then I just want to divide them according to our pattern. So in this case, P will be true and true, false and false. Q will simply rotate, true to false, true to false. And now I know the truth value of P and Q in the argument all the way through. So the next step is to lay out the argument in a single line in order, premise 1, premise 2, and then conclusion. And so our first premise is if P then Q. You want to put a single slash between this premise and the second premise. And then you stick in the second premise, which is in this case quite simple, just P. And then you want a double slash. Now the double slash is essentially telling you you've reached the conclusion. The conclusion will always go at the end of this, and it is delineated or separated from the premises by this double slash. If you see a single slash, you should be separating individual premises one from another. And then, of course, the conclusion, in this case Q, goes on the end, separated by this double slash. Now, we've laid out the argument with all the premises and the conclusion in order on a straight line in this truth table. And so now remember the next step is that we have to determine the total truth value for each and every one of these pieces. So I need to figure out what the total truth value is of premise 1, which means I need to know the truth value of that entire conditional statement. And then I need to know the truth value for P, for premise 2, and the truth value for Q. And of course, those are pretty easy to sort out since we've already determined the total truth value of our simple terms. So we can walk through this step by step. And the first step is to simply transpose our truth values for the individual simple propositions P and Q. And in this case, what we want to do is figure out what the total truth value is of premise 1, which is our conditional statement. So we simply stick the total truth values, all 4 of them, underneath P and Q appropriately. And of course, at this point, we're now in a position to determine the total truth value of this conditional statement, or the entire premise 1. Notice the conditional statement, if you remember, is going to be true in every possible arrangement of our truth claims between the antecedent and the consequent, unless the antecedent is true, but the consequent is false. And of course, we do find that in the second line. So the basic arrangement of truth terms for premise 1 will be true on the first line, false on the second, true on the other two. So now that we know the truth value of premise 1, we can determine the truth value of premise 2. And of course, premise 2 is quite simple. Since it is just our simple term P, we need to simply transcribe those truth values onto the appropriate lines. So we get 2 true and 2 false. And then we can do the same thing here with our conclusion, which again is quite simple. Since it is itself just Q, just a simple proposition, we need to transcribe the truth values of Q from our truth table over to and underneath the conclusion. So we get true, false, true, false. Now that we're finished, the result is quite simply that we know all of the total possible truth values for both of our premises and our conclusion. And of course, all the stuff that you see here circled in red, or in the dotted red line, is what we're interested in. These tell us the total truth values of our premises and our conclusion. Anywhere else you happen to see true and false, all the stuff I have in light gray, is at this point simply irrelevant in terms of using this truth table to determine validity. So how do we determine validity now that we've sorted out all of the truth values? Well, remember the basic rule is that if I can find any possible line here where both of the premises in this case are true, but the conclusion is false, then we know it is invalid. But if none of these possible lines produce that result, then it has to be a valid argument. Now, one of the kind of weird things about this is it's valid when you don't find what you're looking for. So basically, when you fail to find what you're looking for, that ends up being a good thing. But if we look at this, notice the 4 possible lines. The first line, all 3 are true. Then we get false, true, false, true, false, true, and true, false, false. I don't get what I'm looking for. I don't find a situation where both premises are true, but the conclusion is false. And that tells me that this must be a valid argument. And so we now know that this particular argument, if P then Q, P therefore Q, is a valid form. And we just need to write that down, and we're pretty much finished at this point. So let's take a look at a second example. And again, one that's fairly simple in terms of the logical structure of the argument and in terms of setting up and using the truth table. This argument looks a lot like the one we just saw with a slight twist. This argument says if P is true, then Q is true as our first premise. The second premise says it is not the case that P is true, and the conclusion drawn is it is not the case that Q is true. So remember, what we need to do is set up a truth table and then take all of our possible simple terms and lay them out on the left-hand side of our truth table. In this case, once again, we only have 2 terms, which means we need exactly 4 lines. If I had 3 terms, I would need 8 lines. If I had 4 terms, I would need 16 lines, and so on. So you can see how this would start to get pretty dang clunky and complicated if you start to have a whole bunch of different terms here. So we're sticking with easy ones for now. But notice then, I want to just apply the truth values for each and every simple term using the rules we've already seen on how to set up truth tables for individual propositions. So in this case, P will be 2 trues and 2 falses. Q in our 4 lines would be true, false, true, false. And then, of course, we want to just lay out this argument in a row on the top line, premise by premise, till we get to the conclusion. And so premise 1 here is simply what we saw before, if P then Q. We need to separate this with a single line since I have another premise. A single line separates premise from premise. Premise 2 says not P. And if you notice what I've been doing here with the little premise indicators in red, is that I've been setting them over the main operators. This is something I would suggest you do. You don't have to, but it's a very useful tool for sorting out what you need to solve for. Because in the end, premise 2, in order to solve for it, I need to know what the total negation is. That's the main operator. Premise 1, of course, is our conditional. And so notice the little P1 is sitting above that. So it's a nice little way of indicating what it is that you need to solve for. Then we need to place our double line. The double line, once again, is separating all of our premises from our conclusion. So when you see the double line, what follows should be your conclusion. And then we stick our conclusion at the end, not Q. And once again, notice that I've put that little C, the conclusion indicator that's in red there, right above the negation or the tilde, because that's what I need to solve for in order to determine the total truth value of the conclusion. So at this point, we can just start walking through each premise and the conclusion and sort out the total truth value of those claims. The first step is to simply transpose the truth values of our two simple propositions P and Q as they're found on the truth table to the left. So P will be 2 true and then 2 false for our 4 lines. Q will rotate true, false, true, false. And now we have the truth values for our antecedent and consequent. And that means the next step is to figure out what the conditional statement says. As we saw before, a conditional statement is only ever false when I have the antecedent is true and the consequent is false. And that is the second line. So we end up basically with what we saw in the last example exactly repeated. The first line is true, the second is false, and then the bottom two would be true as well. So this is the total truth value of premise 1, true, false, true, true for 4 lines. Now that we've solved for that, we can move on to the second premise. The first step is to simply transpose over to P the truth values for that simple proposition, which is 2 true and 2 false. And of course, we need to negate that. And when you negate, you simply turn everything to its opposite. So if it's true, it becomes false. If it's false, it becomes true. And so premise 2 in the end gives us this result. Notice the total truth value of premise 2, what's sitting underneath the tilde there, is false, false, true, true. And now that we know the truth value of that premise, we can finally move on to the conclusion and follow the same basic steps. The first step is to take the truth values of our simple proposition Q, which is true, false, and simply place them underneath the letter Q. And then we need to simply negate it. So the next step is to negate each of those terms. Anything that's true becomes false. Anything that's false becomes true. And now we've figured out the total truth value of the conclusion. The conclusion, the truth value, is going to be sitting in this case directly under the main operator, which is the tilde. We get false, true, false, true. So now that we figured out the total truth values of each and every premise, we can now apply the basic rule and look to see if it's valid or invalid. And of course, these are the lines we're looking at. The fact that there are all these other trues and falses sitting around it under P's and Q's and elsewhere is totally irrelevant. You just want to go to your main operator once you figured out the total truth value of that premise or conclusion and focus exclusively on these things. It doesn't hurt to circle it like I've done so you know what you're looking at. And of course, what we want to do is look at each individual line and see what the total result is. What I'm looking for is any possible line, doesn't matter how many I get, but if there's even one, it's a problem. Any possible line where both premises are true and the conclusion is false. And of course, in this case, we find that. We find on the third line where P is false and Q is true, the resulting truth value of this argument produces 2 true premises and a false conclusion. And the fact that this argument is even capable of producing that result tells us that it must be an invalid argument. That's how we use truth tables to determine validity. So in the end, this proves to us concretely and necessarily that the argument we saw, if P then Q, not P, therefore not Q, is always and necessarily an invalid argument. Let's take a look at another example. We'll just run through a few more to keep practicing. So in this case, a little bit different. We have as a first premise P or Q, and the second premise says it is not the case that it is P or S, and the conclusion says therefore not Q. So notice here we have three different terms, P, Q, and S. And of course, that starts to complicate things very quickly because if I have three terms, I would need 8 lines total, which means writing a lot of T's and F's in this entire truth table. So the pattern you want to follow once you know all of your simple terms is to take the total number of lines you need, divide it in half, top half are true, bottom half are false, and so on. Just keep this pattern going. So now with the 8 lines that we're looking at, we know that P has to be 4 true, 4 false. Q will rotate 2 true, 2 false all the way down. And then our final term should always end up being a single term rotating, true, false, true, false. And again, what this accomplishes, if we simply follow that pattern, is it gives us every conceivable truth relationship between these three terms. Now that we have the truth values of all of our simple propositions, the next step is to simply lay out the argument in a line on the remaining part of the truth table on the right hand side. So step 1, take your premise and plug it in where it goes. We have P or Q. Notice then we want to put a slash between this premise and the next premise. And again, a mere suggestion, it doesn't hurt to write premise 1 directly above the main operator so you know exactly what you're looking at in order to find the total truth value of that premise. So notice P1 is sitting above the wedge or the either or claim. We have our slash, and then we want premise 2 laid out next to it. And of course, our main operator in this case is a negation. So that's where you might think about putting premise 2. And then we get our double slash. The double slash is separating our premises from our conclusion. And we can finally stick our conclusion at the end. And of course, the main operator here is going to be the tilde, since in order to know the total truth value of the conclusion, I would need to first determine the truth value of Q and then negate the whole mess. So what we can do then is simply walk through each premise and the conclusion and determine the total truth values. The first step is quite simple, transpose. Take the simple propositions in your statement in the first premise here and simply plug in all of the appropriate truth values. For P, we want 4 true, 4 false. For Q, 2 true, 2 false, 2 true, 2 false. Just follow the pattern that you have laid out on the left-hand side and plug in under each of the simple terms the appropriate truth values. Now that we know the truth values for both of our disjuncts, the next step is to figure out what that says in terms of a disjunctive claim. And of course, if you remember, a disjunction is only ever false if both disjuncts, that is, both sides of that little wedge, are false claims. And so the only place that we find this in the entire 8 lines is on the bottom 2. Everything else would have to be true. So we get 6 truths and then 2 falses. That's the total truth value of premise 1. And so we can basically focus our energies entirely on this line. All the other truth values are irrelevant. It doesn't hurt to just circle this. Now you know what the truth value for premise 1 is. Let's move on to premise 2. Premise 2 is also a disjunctive claim, but the entire thing is being negated, so we have multiple steps to take here. The first step is to simply transcribe the truth values of our simple terms. So P and S. P is going to be 4 true, followed by 4 false, and then S will just be rotating true, false all the way down. So transcribe the truth values for the simple terms. The next step here is to figure out the disjunction and its total truth value. So we haven't finished yet because we'll have to negate all this to know the total truth value of the premise, but we can't get to the negation until we know the truth value of this disjunction. And remember, a disjunctive claim is only false if both terms are false. And so we find that in the 6th and the 8th line towards the bottom there. Everything else is true. And so notice we now know the truth value of the entire disjunction, and we need to negate this. And that's important that you recognize all the other stuff that's sitting under the P and S is no longer relevant to us because we use those to determine the truth value of the wedge. And what we're negating now is this line, the wedge. So of course, what we want to do is take anything that's true and convert it to false and vice versa. So once we do this, we find that most everything in here is false except for the 6th and 8th line, which were false before. They become true. And now we know the total truth value of premise 2. And again, what's important here is none of the other true and falses that you see under the P, the S, or the wedge are relevant anymore. All that matters is the total truth value that you find under the tilde, because that represents the total possible truth values of the entire premise. And then we can move on to our conclusion. In our conclusion, of course, step 1, we want to take the truth value of Q, which is rotating 2 and 2, 2 true, 2 false, and so on. And then we simply need to negate this. And when you negate, anything that's true becomes false, anything that's false becomes true. And now we know the total truth value of our conclusion. So we find the two premises in the conclusion are identified by what you see here in dark. And it doesn't hurt to just outline those so you know what you're looking at. These are the only lines, since I have two premises and one conclusion, there are only 3 lines I care about, and these are them. So what you want to do is just walk through each line step by step and go look to see if you find what we're looking for. Remember, what we're looking for is any possible line in these 8 lines that we've seen that can give us all of the premises as true, but the conclusion is false. And if we start walking through this, we find eventually that one of them does indeed produce what we're looking for. Towards the bottom, we discover that on the 6th line, where we have P is false, Q is true, and S is false, if in this argument those particular truth values were assigned to our simple terms, the result would be that all of the premises would be true, but the conclusion is false. And this, of course, tells us necessarily that this is an invalid argument. And so what we've done by way of this process is prove that the original argument, which is premise 1, P or Q, premise 2 says it's not the case that P or S is true, and then the conclusion says, therefore not Q. This argument must be an invalid argument. Another example, example 4. This argument is a little more complicated. It says, premise 1 says P or Q. Premise 2 says if P, then S, and if Q, then S. And the conclusion says, therefore, S is true. Now, in this case, once again, we have 3 terms. If we had 4 terms, I would need a ton of lines, and I wouldn't really be able to fit it on the PowerPoint, which is why we're not going to do it. But basically what we get is P, Q, and S, 3 terms. We need 8 lines, and so we want to sort them accordingly. The first line would be 4 and 4, the second 2, 2, 2, 2, and then we get individual rotation, true, false for S. So set up your truth table with and ascribe the truth values for each of your simple terms by assigning them according to the pattern that we know. The next step, of course, is to lay out the argument in a straight line on this particular truth table to the right. So premise 1, P or Q, goes here. And again, it doesn't hurt to write a little P1 or something like that to indicate what your major or main operator is there, which in this case is simply a wedge. It's a disjunctive statement. Divide this premise 1 from premise 2 with a slash. In the end, of course, premise 2 is just a conjunction, an and claim, but it turns out on each side of that conjunction, the conjunct is simply a conditional statement. And so I want to lay all of that out in a straight line, put the little P2 if you want to above the and so you know what your main operator is, and then we need to simply keep moving on. So we put our double slash in place. This separates both of our premises in this case from the conclusion. And then we throw a conclusion at the end, which is simply S, so there's not much to do there. And since S is the end game, that's the only thing to play with. Put the little conclusion indicator right above it so you know that that's the line you're looking for. So we can move on. Let's solve for the total truth values of premise 1. The first step is to transcribe. Take the truth values of P and Q here and lay them out underneath each of these simple terms. And then, of course, what we're looking for with a disjunctive claim is any possible line where both of the disjuncts are false. That is the only time that a disjunctive statement will be false. And of course, we find those at the end with the bottom two. This is the truth value, the total truth value of premise 1. We get everything true except the bottom two. And so you might circle that so you know what you're looking at. This is all we care about premise 1, and we can move on now to premise 2. Now notice premise 2 has a whole bunch of stuff working out here. We have P and S, Q and S. All of our simple terms need to be transcribed where they go. Under P, we should have 4 true and 4 false. Under S, we want to rotate true, false, all the way down. And Q will rotate in sets of 2, 2 true, 2 false, and so on. So transcribe all the simple terms over. And of course, we can't figure out the conjunction, the and part of this, until we know the total truth values of each side, that is, of each of our conditional statements. Now, notice with a conditional statement, what we're looking for is any possible arrangement where the antecedent, the first term, is true, but the second one, the consequent, is false. And we find a few in there, a couple in each. I won't explain where they go. So just run through and figure out where those go. We get true, false, and then true in the first one, true, false, and so on. Figure out where they go. And then, of course, in order to figure out the truth value of the conjunction, what I need to do is simply focus on exclusively these middle lines. That is the truth value for the entire conditional statement. So at this point, everything that sits under the P and the S and the Q is irrelevant because in the end, my conjuncts are themselves conditional statements. So now that I have the truth value of both conditional statements, I'm in a position where I can determine the truth value of the conjunction. And of course, with a conjunction, what we find is this is true if and only if both terms are true. So if there's a false anywhere, then this has to be a false statement. And so what we find are there a handful of truths in this as we wade through them. Just run through it as you properly should. And now we know the total truth value of the second premise. It's true, false, true, false, true, false, true, true. That is every possible truth relationship that could exist for this simple statement, premise 2, if P then S and if Q then S. And of course, we want to move on to the conclusion. Now, the conclusion here is painfully simple. Since it is S and S alone, all I need to do is transcribe and then I'm finished. So these are the truth values for our two premises in the conclusion. And at this point, that's all I'm looking at. I don't care about anything else in the argument. All the other T's and F's that you see can pretty much go away. Now I want to figure out, do any of these lines produce the result that I'm looking for? What I'm looking for are both premises in this case to be true. If I had more premises, all of the premises are true. And then the conclusion is false. And so if we run through each line individually, we find true, 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 doesn't give us what we want. True, false, false, doesn't give us what we want, and so on. As we wade through this, we discover quite simply that this is a valid argument. I do not get any line anywhere that produces a result where all the premises are true, but the conclusion is false. And what this means is that this argument's form is quite literally incapable of producing that result. And that tells us that it is necessarily a valid argument. So at this point, I'll stop running through examples and simply point out a few things here. To begin, what we will see in the next module is that there is a shorthand way of dealing with truth tables so that you don't have to deal with all of the absurd tedium of writing all these little T's and F's under every last dang thing. We will use ultimately indirect truth tables to solve for validity, but you can't understand how an indirect truth table works unless you know how a full-blown truth table itself works. And as you can imagine, notice all the examples we gave either had 2 terms or 3 terms, so we maxed out at 8 lines. You can imagine, frankly, quite plausibly that this would get unbelievably challenging if you had 5, 6, 7, 8, or 9 terms in an argument. At some point, you would start to need a computer, and if you kept going, a computer might even get taxed on this point. So we will find a shorthand way of dealing with this. At this point, though, what you need to do is simply practice. The more practice, the better. Practice, 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 and you'll get pretty good at running through all of this nonsense.